Welcome back. In this session, I'm going to give you a quick overview of the storage solutions available in Azure. To set the expectations, this is a vast topic. I'm just going to give you a quick introduction that is sufficient for you to do this course. If you want to learn more about the various storage options available in Azure, please use the links that I've given at the end of this module. Data from modern applications come in different shapes, sizes, and frequency. For example, e-learning platforms such as Skills.Progty may have a number of distinct data sets those are used to run the business. Skills.Progty may have structured data detailing the students' personal data and their financial transactions with Skills.Progty. Unstructured data from the system logs, and also there are training videos to serve the platform. There are students and teachers accessing the course and streaming videos from around the world. Each dataset, such as the student details, system logs, and videos, have different storage and operational requirements. It's our job as data engineers to figure out the best storage solution. No one solution fits the need of all of this data. So, the key factors you need to consider in deciding the optimal solution for our data are, firstly, structure the data. Your data may be structured, semi-structured, or unstructured. Structured data is data that neatly fits into rows and columns. A spreadsheet with rows and columns could be considered as structured data. Examples of semi-structured data are things like JSON files, XMLs, and YAML files. And examples of unstructured are system logs, photos, videos, and any kind of media or documents and things like that. The next key factor to consider is operational needs for the data. We need to think about how the data will be used. This will be things like how often the data is used. How quickly do we need to serve the data back to the user? Do the users run simple queries or complex analytical queries? Are the users located in one Azure region or across multiple regions? Etc. Azure provides a number of solutions to store and operationalize data based on these key factors. So, let's look into those ones. Let's consider the database offerings first. We have the following database solutions to process structured data. Azure SQL Database, which is a fully managed cloud-based database that runs on the latest version of the Microsoft SQL Server database engine. Azure Database for MySQL, which is a fully managed enterprise-ready community MySQL database as a service. Similarly, we have the Azure SQL Database for Postgres and MariaDB, which are fully managed enterprise-ready PostgreSQL and MariaDB database as a service on Azure. On top of this, we have the option to use the marketplace to provision a whole host of virtual machines with databases pre-installed in them, such as Oracle SQL Server or PostgreSQL. Next, let's consider Azure Storage Account. Azure Storage provides a variety of storage solutions under one umbrella called Azure Storage Account. For those of you familiar with AWS, this could be comparable to Amazon S3. There are currently 5 types of storages available under this. Blob storage that can store unstructured data such as text files, media, documents, PDF, and that kind of information. File storage offers a fully managed cloud file store that you can access from anywhere via SMB protocol. Disk storage for storing virtual machine disks on Azure VMs. Table storage that lets you store structured data in the form of key-value paths. And finally, queue storage that can be used to store and retrieve messages from the queue. Azure also provides us with storage solutions that are specifically designed for big data analytics. Lake Storage Gen2 is a storage solution designed for building enterprise data lakes on Azure. This solution has been designed to service multiple petabytes of information while sustaining hundreds of gigabytes of throughput. This is built on top of the Blob storage with additional features, such as enhanced performance for big data analytics and support for Hadoop-compatible workload. Enhanced management. With its hierarchical namespace, better security using POSIX permissions on folders and files. As it's built on Blob storage, it's also inexpensive to run. Azure Cosmos DB is another storage solution offered by Azure. Cosmos DB is a fully managed NoSQL database for modern application development. It's globally distributed, which allows us to elastically scale throughput and storage across any number of Azure regions. It supports a number of APIs to access the data such as SQL API, Cassandra, MongoDB, and Gremlin APIs. It provides near real-time response times for a variety of data. Typical applications that benefit from Cosmos DB are web, mobile gaming, or IoT applications. Those need to handle massive amounts of data reads, writes, global scale with a near real-time response. So far, we've seen a number of storage solutions. Amongst those, we will be using the following storage solutions in our project. Azure SQL Database. This will be used as our reporting platform for Power BI. So, once we process the data in our data lake, we load them into Azure SQL Database and Power BI will report from there. Azure Blob Storage. This will be used as a data source for one of our data sets. Also, we'll keep our scripts and config files in this. Azure Data Lake Storage Gen2. This is our data lake for our project. Hope this has given you an understanding of various storage options available in Azure and the storage options we are going to use in our project. So, that's the end of this session. In the next session, we'll create these resources required for our project.